It's really annoying when we're talking about antiderivatives to have to keep writing find the antiderivative. So what we want is some sort of mathematical notation which indicates that we're finding antiderivatives. If f is a function, then the indefinite integral of f, which we denote using this integral sign here, is the set of all possible antiderivatives for f. We know that antiderivatives are unique up to an additive constant, so we're often a little bit sloppy with our notation. For example, if f of x is the function x squared, then the indefinite integral of f is 1/2 x squared plus c. So we haven't written our answer in set notation, but instead written plus c at the end to indicate that we're iterating over all possible real numbers. Now that plus c term is absolutely critical. Remember, the indefinite integral is the set of all possible antiderivatives. So if you forget the plus c, then you've only written down a single antiderivative and missed infinitely many. We can now translate the properties of the antiderivative into those of the indefinite integral. For example, since finding antiderivatives is linear, so too is the indefinite integral. The integral of the sum is the sum of the integrals, and we can pull real number scalars out of the integral. So we've done lots of antiderivatives already, but let's do one more example just to solidify this. Let's find the antiderivative of this function. Now you don't want to attack this head on, right? You're not going to be able to see the answer immediately. Instead, let's start by splitting the fraction into 3 pieces, all of which have the same denominator, x. Now we'll do some cancellation to simplify our expression as much as possible, and then use linearity to break this into a bunch of smaller antiderivatives. Now each of these can be integrated pretty quickly, and we remember to throw in our plus c for good measure. And one final note that sometimes comes up, even though there are 3 indefinite integrals in this expression, we only need a single plus c. And if you don't see why immediately, you should spend a bit of time and think about why this is true. So the indefinite integral is a convenient mathematical notation used to indicate antiderivatives.